All right. So I think we got through most of these, right? We didn't do too much with the resize. We did a little bit here. Um, this idea of when we loop through vectors, right? We've got two different ways of going about it generally. Right? We could use the index notation. And look, everyone loves I. I hate I. That's okay. If you like I, go for it. I'm just always going to use index because that is more meaningful, and that's what I like my variable names to be. So we'll do that. If you don't need to change them at all, right? If you don't need to modify the values there, we can use that enhanced loop. I think we had that one. They skip it. They skipped it in this one. So there are two different ways of doing our loops. More of a read-only style loop. This is the enhanced for loop. That was in a different part. That's right. We've got it here. So the notation looks a little funny here. So each individual item in the vector, we're going to call score as we loop through it, right? So it's the same way as doing it by index, right? So you could say for int index is 0 index, and we're always going to go less than the size, right? Because remember, if you have 5 items, you have indexes 0, 1, 2, 3, and 4, because we always start with zeros, right? Index plus plus. So I would just, again, check here and say, hey, instead of score now, it's my numbers at the index, right? And if it is, then my max score will equal the numbers at the index. So just kind of swapping out that notation. So if you only need to read the values, this is less typing, right? But if you ever want to modify the values, if you want to work with them and interact with them and do something with them, we've got to use the index notation because then we can actually change the values and do something with them in the vector. Because this gives you access to where it is versus this is a copy, right? When we write functions, by default, we pass things by value. So we're passing a copy here. So you're getting a copy of the value each time here. Uh, so like this one, then we can actually go and modify. Right? So you can assign to those locations, or you can just use them to get. So the notation's a little weird. But just like any other variable, right, you can, if it's on the left of the equal sign, you're assigning to it. If it's on the right, you're just getting the value back out. So it's doing the same thing we've done with variables. They look funny now because we're saying, hey, find the specific variable at this index in this vector at this location. That's all that does for us. Does that make a little bit of sense? Right? And then if you want, again, this is not a good way to go about things, but you can. And some people will do this sort of thing, and that's okay. We haven't learned better ways yet. We'll get to the better ways. Which chapter? The next chapter? Next chapter, yes. Next chapter, we'll get to the better ways, which are so much easier than having three different vectors, and you have to remember indexes and things like that. So we'll get there. Okay. All right, but those were vectors. Remember, vectors, they start empty, and you start adding things to them. If you want to size them ahead of time, when you create the vector, you can say, hey, I want a vector of, we'll call this int here, and this will be my, how about a lotto ticket? We'll say, hey, in parentheses, you can give it, how many numbers do you want here? I'm going to put 6 integers in this vector. They're going to start off empty as my default. So they're all going to be 0 to start. I think 0. We should actually check that. Let's try it. So number in the lotto ticket. Got the number. Let's see what we get here. Maybe I'll put that at the top, actually. We want to run that at the top. Oh, we still have hello world. Let's see. Yeah, all the zeros. So by default, you get your default value. So we get zeros. So defaults creates vector of 6 zeros. Does that make sense? Then we can go through and I take my lotto ticket at 0 and assign it a value like 1 and so on and so on. So if you want to go buy a lotto ticket and you want to pick your numbers instead of it being like an easy pick, oops, go through and say, okay, let's put 1 and 2 and 3 and 4 and 5 at different values. So if you wanted to go buy a Powerball ticket, because everyone loves to buy Powerball tickets because the state makes a lot of money off the lottery. Uh, sure. That's why they advertise so much. In case you hadn't noticed, like all the billboards and things, that's the state because they make money off of it. You know who doesn't make money off the lottery? People who play. Yeah. Okay. Anyway, sorry. We'll talk more about that later. I have opinions in case you didn't notice. And just give it some different values. So if you precise it here, we've got these different indexes, they exist, I can go set values. If we don't presize it, vector int, well, it's like a random ticket, I can't now go and say, hey, at 1 or at 0, right, equals rand mod, so what is it, 69, I think, flip 1, because you want 1 to 69 for the white numbers for Lotto Powerball, right? You won't be able to do this because those locations don't exist, right? There are no indexes there, and then the Powerball is 1 to 26, I want to say. That sounds about right. I always have to go look it up, right? So this will fail on us because we don't have values at those indexes. Did it not fail? Oh my goodness. Hang on. Stop. Oh goodness. Cancel. I tried killing it here. That's interesting. Let's put a breakpoint here. It was supposed to fail. Let's run in the debug mode, see what it does. All right, so we got our lotto ticket, right? And we can expand it open in debug mode. You can see the different values. So it's super handy to see your values in debug mode as well. Then we've got random ticket that has nothing here. So let me add. Oh, it's just not doing anything. That's awesome. Okay, so it's not crashing. It's just not assigning anything anywhere, right? Because there is no index there. So I wouldn't know that this didn't work until I go and try and get these values back out, and I don't get any values out, right? Say, out or random, your easy pick numbers are, and then let's go and get these values out. Maybe a space. Oh, we'll just have a bunch of this. 1, 2, 3, 4, and 5. Let's continue. Did I do the wrong thing? I did. I'm dumb. I didn't change my variable name. I copy pasted. I used lotto ticket, not the random ticket. You guys gotta catch me when I do dumb things. Okay. This is why it wasn't crashing on me. Easy pick. There we go. Let's try that one more time. This should do what I want it to do now. Yeah, all right. We crashed out of range at memory location. There was no index there. That's what I thought would happen. So if you try and get at an index that doesn't exist, the program crashes on you. And that's always sad, right? We give it a run, it just crashes. Continue, crashes, 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 crashes. Access violation writing location. It's crashing. It's not going anywhere, right? Our program died. So if there are no indexes there, we can't use them. But it's actually sort of a good thing it crashes on us. We like that. That's what we want it to do. Why does Battle.net want to keep logging me in? It's weird. All right, so this fails unless we presize the vector. And again, hopefully you see like doing this 5 times is kind of silly. It was fine to copy paste, but this would be a really easy loop instead, right? Yeah, we could do a loop, right, for int number 0, number less than 5, number plus plus. Okay. And then instead of saying, hey, at here, we can just push back, right? Say, hey, go add 1 here for me, please. Let's go add a value. Now we can go add the values here. And then the last one, right, we can push back this as well. Push back for random value 1 to 26. So now we'll have numbers because you can add to empty vectors. Okay, cool. So our easy pick numbers, 42, 45, 56, 5, 57, 21. And again, we're going to get those same numbers every time we run it because we didn't seed random. Right? Because remember, random's not actually random; it's just pseudo-random. Right? We know what the algorithm is, so it can't be all that random. All right. So we can get some model tickets. So those are our vectors. Okay, if we want to use arrays, then they're similar to vectors, but arrays can't be changed in size. So we're vectors, we can add to it. We can even remove from them too. We haven't done that. I'll take it. Oh, gotta do it after. Sorry. Let's go down here. Model ticket dot. You can erase, which is kind of fun. You can insert at specific locations. You can get the front value out. You can get the end value out. There's some fun things you can do with your vectors. When we have an array, it's fixed in size, and that's why they're slightly more efficient, a little bit faster than vectors. Things behind the scenes have to happen with vectors as we add numbers or take numbers out. Um, so we pay for that flexibility with performance just a little bit. If I want a bunch of numbers, I'm going to say, hey, I want an integer, and then I use square braces to say an array. So I'm going to say, hey, I want 6 integers here. We'll call this, oh, sorry, on the wrong side, int. We want this like my numbers, 6. I think can we put it here? 6 other numbers? I don't think we could. No, so you put the square braces after the variable name here. Looks kind of funny here. So this square brace notation uh, for arrays. So you tell it how many values you want in the array, how large you want this array to be. Now it's kind of fun behind the scenes. Let me draw a picture here because pictures are worth 1,000 words. When you create an array of size 6, C++ goes out and asks your operating system for enough memory to store 6 integers. Right? So that needs 24 bytes. Wow, look at that. I can write with my mouse. That's awful, I'm sorry. But your operating system says, oh, sure, here you go. Here's that, X. And we use these hex notations for memory addresses because it's fun like that. So 2FB0 or something. Sure. Right, we get some memory address. And then you get place to store 6 integers. 1, 2, 3, 4, 5, 6. I should have brought my little tablet to draw. It would be so much easier. And 2FB0 is the location where this starts. And then every 4 bytes, now I can put the next integer. So this is going to be B and 4. This will be B and 8. And this will be B. And remember, when you count in hexadecimals, you don't roll over at 9 back to 0. You just keep going. So you get 8, you get 9, A, B, C. Because why not, right? So that's C. And then after C, we get D, E, F. Now we start to roll over because that's the 16th character. So now we roll over. So this would actually be C and 0. So B goes up to C, goes up to the next one. You can learn more about hex later. You'll get sick of it if you go on and take 310. But it's not really worth keeping in your head. It's just fun ways to count. This would be C4. So all the different memory addresses. So when you say, hey, I want my value at a specific index, what C++ does is says, okay, what's the index? So I've got 6 different indexes here from 0 to 5. Which one should we go and read? We can pick any number. 2. All right, if we're going to read index 2, I'm going to take this number here, and I'm going to add index 2 times 4 bytes, because that's the size of an integer. So it knows where the array starts, because that's my memory address. That's where my array starts. And then index 2 says, okay, if I'm storing integers, I need 2 times 4 bytes. That's 8 more bytes. So then I'll read B8 to get the second index here. So that's why everything starts at 0. So if you want the 0th index, you're getting your memory address plus 0. Because that's where it starts. That's where you can read 4 bytes. So that's why everything starts at 0. It makes the math fast for computers to figure out where it needs to go read things out of memory, which is super fun. Right? So now I've got my numbers, and now instead of using .at, I just use the square braces. I say, okay, I want index 0 to be, what number should we put in our lottery ticket? What's a good lucky number? 7. All right, and then my number's index of 1. We want to assign a value of 13. My number's index of 2. All right, I'm just going to copy paste this. Equals what? And then go and do a bunch of numbers here. 2, 3, 4, and 5. Right? All right, what other numbers do we want? Lucky numbers. 21, 9. We've got prime numbers. We got multiples of 3. What else are we doing? 5. All right. All right. 5s, sure. Well, 15, because that's a 3 and a 5. Multiples. All right. So we can assign using the index notation. So it's variable name and then square brace what index. So I usually read this and I would say at when I see square braces. Like my number's at 0, my number's at 1, and that works out well because when you use vectors, you actually use the at method or function here, right? So, or you might say index of. My number's index of 0, index of 1, index of 2. I just like saying at because then it matches vectors, but anything's fine. So we can go do that, and then we say, hey, my number's, what about index of 6 equals 777? Let's see what we get. Oh, build errors. Look at that. It's even failing to compile. Buffer, my numbers of size 24 bytes will be overrun. 4 bytes will be written starting at offset 24. It sounds like garbage, but it's saying, hey, 6 times 4 bytes, right, is 24. There's not room there. You can't go right at this location because we didn't assign that when we created our my numbers array. Wow, that would be no good. I was about to give myself a lot of insulin because of my pocket. So that's why it beeps at me all the time. Sorry. All right. So this is telling us you can't do this. Index 6 is out of valid range, index 0 to 5. Possible stack allocated buffer my numbers. Buffer overrun. So we get all sorts of nice warnings here. Our tool is being very helpful. It won't even let us compile here because there is no index 6. Right? That's no good here. So if I wanted to go through, now, the problem with arrays here, right? If I say int index is 0, index is less than my number's dot, there's no dot. There's nothing here. If I put dot, I'd get nothing because my numbers in a basic array, vanilla array, is not an object. So there's no functions on it. Again, doesn't make a whole lot of sense when we talk about the next chapter. But with vectors, we can say dot and we get a bunch of cool stuff. You can interact with them. There's functions we can use. Arrays don't do that. So I like, uh-oh. How do I know where I need to stop here? Like in my code, sure, I can say, okay, yeah, sure, it's 6, so less than 6, because I can see I sized it at 6. Let me put in 7 just for fun. Index plus plus. And let's just do like a total here. So we'll have an int for sum, 0, and then we can say sum plus equals my numbers at the index. Right? And then we can see out sum of array numbers, array values, and the sum, and then an end line. Let's give that a try. That one didn't crash, but we got hot garbage. The sum is negative. What? I need one of those meme pop things. The what theme. That's a good one with the rubber ducky. I like that one. All right, what happened here? Well, let's go take a look. I'm gonna put a breakpoint in here so we can watch it run as we go. Oh, look at that. It's starting to warn me. All right. So right now, sum is 0, right? Sum starts at 0. Index is 0. Let's go read the first value. It should be a 7. Okay. So sum now is 7. Right? We can see sum is 7. Right. Again, it's a little small here. Sorry. Sum is 7. I think there's if I hit pin, there we go. It'll stay here on the screen, which is really nice. And now sum goes up to 20, right? We've added 13 to it. And then we're going to go and add 21 to that. So we should go to 41. And then we're going to go and add 9. So we should go to 50. Right? And we're going to go and add 5. We should be 55. We're going to add 15. We should be at 70. What happens here now? My numbers at index 6. Do we have a value at index 6? No. So we just went and added a bunch of garbage here. So when you use an array and you try and read a value at an index that doesn't exist, you get garbage out of memory because we've told C++, hey, go read the thing at this memory address plus 24 bytes. Well, there's something there in memory, right? Because they're either 0 or 1s, and that's what's in memory right now. And you're on, you're off with our bits here. So there is a bunch of bits there that are either on or off based on whatever it happens to be in my computer right now. I don't know what's there right now, right? And it read some garbage value out. Like, here you go, here's garbage. Because I told it to go read that value. So this is another reason I dislike arrays, because they're dangerous. Like, you can shoot yourself in the foot with it. Because it's like, okay, sure, want to add this? Go for it. Now it's telling us, right, and we're getting a warning here, index 6 is out of range. But when we're just reading values, it doesn't crash on us, right? But when I tried to write to that value, the compiler was like, hey, dummy, you can't do that. It wouldn't even compile. When I go to read it, it's like, okay, I'm going to warn you you're being stupid, but I'm going to let you do it anyway. That's weird. I think I was reading something about this. Some of the old, so the old Nintendo games did some weird stuff about reading memory, and some speedrunners were found out a way they could hack what was in that location in memory and read it. Does that sound
Yeah,
ring a bell?
like a south selves or do things so like obviously
I'm trying to remember what it was.
It's for Mario 64. You can't go past the stairs that go to Bowser unless you've gotten a certain number of stars. And so you can use the memory to just basically say, I have this, and then go to.
Does that count as a valid speed run? Because you like
It's in there.
hacking the memory?
I think it depends on the category. Which it's now.
Mhm. That the whole idea of speedrunning games is super interesting. And there was one speed run someone got. Oh, where was it? One while they were playing, they like shifted their vertical position a whole bunch on a jump, and no one had any idea what was happening. And the best working theory is some of the cosmic radiation actually flipped a bit in the system because the physical memory can change values based on all sorts of interesting things, and turns out cosmic radiation can change memory, and they've not been able to repeat it, right? But I think they're able to change that bit, like focused. It just never happened randomly, right, or something. So crazy hardware level things can go weird. And that's why when you deal with like stuff on the space station, they've got, I think it's like triplicate values before they actually do anything. They've got it computed on three different parallel systems to make sure the radiation didn't change some of those. Because, right, if you like change one of your values on the space station and you just take it because the computer told you it was the right value, bad stuff can happen, right? So the chance of the same bit being flipped like three different times. Anyway, that's just a fun, weird story. But arrays do weird things and are a little bit awkward here. So you have to be careful. Right. That's all. So let's fix that to be 6. Um, I think there was a way. Let's get number. Maybe say. How do I count the number here? There. Okay. So you can do this thing here. You can get the size of your array, and then you can get the size of the thing in the first spot of the array. So the size of the array is how many bytes does this take, right? And so we know this took 24 bytes. Right? So the size of my array should be 24 bytes. And then the size of the first thing should be 4 bytes because it's an integer. So I can do arithmetic here to figure out how many index values I should have. Now, the dumb thing is you have to do that by hand. Instead of like, hey, just give me dot size and tell me how many items are here, we have to go to the arithmetic by hand. So we should be able to get the size of, so size of my numbers should be equal to size of my numbers, right? And an int of size of uh, single value single value is size of my numbers at 0, right, at index 0, right? So then I should have a size, or I don't know, total values or something like that, indexes, positions, number of values in my numbers is size of my numbers divided by size of a single value, right? We should be able to go and calculate all of this here. And now this should be a little happier. Let's put our breakpoint in. I forgot. Oops. So size of my numbers is 24. Size of a single value is 4. So number of values is 6, right? And this should work out well for us. So continue a couple times, or if I want to move my breakpoint down, I can take it out. Oh, we still have that pin too. How do I unpin that now? Unpin. There we go. So now we get sum of 70, and it's correct. So we've gone through the correct thing. So if you want to do a little extra work, you can go and calculate how many values are there, right? this is really tedious. Another common way of doing that is say constant int my number's size equals 6, right? And then I can use that same value in all my places here because I know that's a constant value. I'm not going to change it by mistake. You always want to do it with constants because it's really easy to change your variables, otherwise. So constants are another good option here for that. And now we can calculate the sum is 70 and we're happy. I don't want, okay, there we go. Stop watching that. So you've got options for doing it. Again, none of them are as easy as just asking the vector what size it is. Right? And again, that's why I like vectors. Vectors are friendly, a little easy to use there. Okay. Let's do make another array here. Let's do an int. This is my other numbers. And let's say, hey, this equals my numbers. Array of 6. Oh goodness, no, doesn't let me do that. My numbers. Initializing. Doesn't let me make a copy. I can't set one equal to another. It's kind of sad. So if I want to make a copy of it, I have to go through and for index is 0, index is less than my number size, index plus plus. Right? And then I can go set the values individually here, my other numbers at index is equal to my numbers at index. So you can copy them one at a time. Right? To make a copy of another, copy, right, at the right size, copy each value. It's a little slow, but we can do it. Right? With our vectors, did we try our vectors? I don't think we tried our vectors. Tried random ticket. Can we say lotto ticket equals, no, I'm sorry, random ticket. Random ticket equals the lotto ticket. Now this one let us do it with vectors. This is kind of fun. So, oh, I don't want to break here. Let's continue. All right, so we've got our random ticket. We've got our lotto ticket. So we know what the values in lotto ticket are. And now let's go and say, okay, random ticket is equal to the lotto ticket. Great. So now random ticket has 1, 3, 5, 7, 9, 11. Cool. Lotto ticket has 1, 3, 5, 7, 11. Good so far. Now let's go and set some random values for the random ticket. Okay, now we don't need to push back. Right. Let's try pushback. Let's see what happens. Random ticket. Okay, so we're just adding values. Again, not ideal. So if we wanted to overwrite, and we'd be able to do that. But so we can make copies with vectors pretty easily. That worked out okay for us. Right, and we would just change this notation then instead of pushback. Should I just comment that out? Let's do that. Let's do our loop. And then we'll just say at number is equal to that, right? We'll just go change the value here. Right, and this last one, we'll change the value as well. At number, or this will be at 5, right? It's the 6th number. Again, if we're making a copy, why go change them all? But you can, right? So we can go and change our values. We're having fun. Right, random ticket gets new values in here. We're just putting in new ones. Our lotto stays the same. So that's okay. So this is a quick copy with vectors. With arrays, you've got to go through and do it the slow way. Copy each value on, right? You can't assign one to the other. All right, how are we doing? How are we doing? So our arrays versus vectors. Let's see. Right, at 0, at 1, at 2, and so on. Okay, so weights, sure. Created the location. That was it, really? That was their chapter? Okay, sure. Two-dimensional arrays. We're going to save two-dimensional arrays, I think, for Monday. We might have time. Character arrays and C strings. These are fun. So we've been dealing with the string class. So if we include string, right, string is technically a class. It's an object. It's a library. It's got cool things we can do with strings. This is in C++. In the original C language, like the predecessor to C++ that was not object-oriented, to make a string of characters, you made a character array. So you could say, hey, I want a char array. We'll call this my name. And Eric is size 4, but then I need a fifth character to tell it stop reading. So you need a terminator character at the end to say, hey, this is the end of the string. So it's always sized up by 1, right? And I could say name at 0 is equal to an E, and name at 1 is equal to an R, and name at 2 is equal to an I, and name at 3 is equal to a C. It's nice to have a short first name. Apparently, when my brother and sister got named Brandon and Amanda, when I came around, my parents they had watched them learn to read and write. It's like it's too hard to learn to write their name, so they gave me a short name. That's why I ended up with Eric. And and there were like 3 other kids in my neighborhood named Eric at the time I was growing up, so they found a nice common one. Anyway, uh, so Eric, and we need the null character at the end. This \0 is the terminator null character. Sure, we can do that. So we'll put in \0. Or backslash is like our escape character. It says, hey, the next thing that comes after this is special. Sure. So we should be able to see out name, and I think this works here. Let's see if we see out name. What do we get? We might not. We might get garbage. Hey, we get Eric. Look at that. It was able to make it work. Cool. Let's try it again here. Let's do name of. Let's do Jub here. Let's see what we get. JEB, and let's forget the other characters. Can I see out? This is Jub. And that line. The right point over here, so we pause. He didn't stop. He was waiting for that terminator, didn't find it, so it read a bunch of hot garbage out of memory. And hot garbage, as characters, is garbage. Right? So without that null character, the terminator, and we try and put it to the screen, C++ is like, oh, sure, you want to read until I find this terminator. It just kept on reading. Eventually, it probably found something that was 0 or whatever. It must have matched. We got lucky, maybe. I don't know. Do we get the same thing every time? It might be a little different every time. What do we get here? Okay, that was fine. Let me flip these around here. Let me put Jub first. I'm gonna put Eric, just to see what I get here. Oh, goodness. No, okay, I was printing Jeb. I did name. I'm so bad at my variable names here. Copy paste is so dangerous. Like how many bugs I get from copy pasting things wrong. Source file change. That's fine. Yeah, run. Debug. Okay. Alright. Cool. Eric, Jeb, trash. Looks like I get the same trash every time. It tries to read it. Like when we were reading values by index and we just kept reading the next one and reading the next one and reading the next one and it was garbage. It's going to warn us. This one doesn't even warn us about it here. So you got to be careful to make sure you are including that null character. So if we go and put that one in here, we size it up 1 more. We got Jeb, 3. Now we should actually be able to get some decent output. Sorry, that was weirdly loud. I think because I wasn't stopping, I wasn't ending my program. There. Now we get basic looking output. Right. Should I leave that in? Let me comment this one out here. If I comment it out, but I'm size 4, sorry. One of these days I'll remember to close it. We get less trash this time, but still trash. That's fun. I stopped it. I stopped. So C strings are just character arrays that end with a null terminator. They're lots of fun. Some people still use them. Now, you can oversize your array here if you want. And as long as you have your null character, you're in good shape. So let's make this like size 15 for Eric. And it's okay because it's going to read until it finds the null character. Look at that. Jeb found Eric in memory. So somewhere in memory, when we put these things out here, right? I created Jeb that's at BEED94, right? That's the memory address. And I've got room for 4 characters. The characters, I think, are 2 bytes each, I want to say. That sounds about right. And the name is at BEED B8. So B8, and this is D94. So if you keep going up and going up and going up and going up, right, eventually we'll get to DB8. And then it found the null character, right? So the way my operating system said, hey, have some spot in memory, it gave some space for Jeb and then some space for Eric. Eric came after, and it happened to come after. I don't think every time we run it, it'll do the exact same thing. I honestly don't know how the Windows operating system works. So some people do, and they're really smart people, and I appreciate them. I just like to make things that go beep boop bop. So we found Eric in memory as we were reading Jeb out. So you can imagine that's probably not what you wanted, right? When you're doing this sort of thing. So weird stuff will happen. If we run it again, do you think it'll work? It did it. Neat. It's kind of repeatable. That's fun. All right, that was enough fun. So as long as it finds the Terminator character, it'll stop, and you can oversize it. If you go and assign a character array to a string, our compiler's like, oh, hey, you want the null character at the end. We know what's happening here, and you're okay. Because it already added the null character for you. It sort of does that automatic conversion, which is really nice. You can loop through and find them. Yep, that's all good. Those are fun. But using string, right, much easier so we don't run into those sorts of problems. You can also use C strings if you want all the stuff that C did with strings. Sure, it's all sorts of fun. Things you get like string copy, or string concatenate, or string n number of characters concatenate. Sure. So ways we can interact with C strings, things they used to have to do back then to make copies, right? Instead of having to do the loop themselves, they're like, why don't we write a function that does this? Yeah, you could use string copy, right? It copies from the destination. I'm sorry, from the source to the destination. And make sure you don't get those mixed up, because that'll be upset. That'll upset you, right? Copies some number of characters, right? So you've got fun things you can do. You can, excuse me, looks for a specific character in that string, gets the length here, right? Some size, which is super handy. Figure out how many characters are in there. This was a nice thing to know. All right. Other fun things you can do with characters now, as we're talking about, right? Strings are just arrays of characters, essentially. You can individually add characters. You can see, is this character alphabetic? There we go, alphabetic. A to Z or capital A to Z. Is it a digit, 0 to 9? Is it alphanumeric? Is it either one of those? Is it white space, right? Is a space or a tab or a new line? Is it lowercase? Is it uppercase? Is it blank? So it's just a space? Is it a hexadecimal digit, right? Which is 0 through 9 or A through F? Is it a punctuation character, which is, sure, I guess those count as punctuation. I don't know. Is it a printable character, which is alphanumeric, punctuation, and space? Or is it a control character? Something like the null character. It's a control character. All sorts of fun things. And then we can convert individual characters to upper to lower. That's fun stuff. So all sorts of cool things we can do with characters and C strings. Thankfully, we've got the string library, and we don't have to do most of that, which is kind of nice. But we can go through individuals. So I'm going to turn on some of these labs here. I'm sorry, I forgot to turn those on for you earlier. Output numbers in reverse, right? So if you need to take this and output them backwards, instead of starting at index 0, going to the end, you start at index of the end minus 1 and go down to 0, right? Because right? In for loops, about the only thing we've ever done with for loops is say plus plus. You can do more than plus plus, right? Or something specifically like minus minus to go down one, right? Hopefully that makes sense. Okay, let me put that back. All right, so that's a good one. Nice, easy practice. The middle item, right? How do you find the item that's in the middle? Right, that's some arithmetic with our indexes. That was fun. Output values below an amount. Sounds kind of like a question I read on the midterm. I swear I didn't copy it off of them. It's just a common thing. Looping through, adjust a list by normalize. This one is super cool. Normalizing lists here. Um, if you get into all sorts of data processing stuff later, want to get into machine learning, this is a very common technique, which is lots of fun. So having a big range of numbers is tricky, especially for plotting and graphing and doing all sorts of who knows what. So we would put them at the range between 0 and 1, and to do that, you adjust them all by the max value. Right, so the max value here is 100, so the max value becomes 1. Everything else is what's the factor between 0 and that, or 1 and that, right? So we can see whatever that scale is essentially. This is a common thing you'll do. That's a lot of fun. Normalizing. Oh, I didn't hit visible. Sorry. We'll go back to that. Would you like the Xylab so far? Word frequencies, we did something similar to that. This is finding a particular word. Often each word is in there. That's a fun one. And contains the character. Hey, we did this one, right? I think we did that in essentially for wow, Hangman, right? I need more coffee. What do you think of the Xylabs? I know they're a little tedious, but are they good practice? When they run, you tell the right or wrong there right away? Usually people say that's fun. Maybe not fun. They say it's worthwhile, right? The more practice you get, the better. I do miss there's no like IntelliSense though. So typing stuff out is really tedious. I get that. All right, you folks doing okay so far? All right, cool. I got to finish up getting the midterms in for you. Again, for the projects, generally your self-assessments are good. I got to get those entered into Canvas. I'm sorry. You folks are pretty good at figuring out whether or not you did it or not. Um, Rarely do I get someone who's like, "Oh, yeah, I got 100%," and they gave me hot garbage. That's pretty rare. You folks are pretty good about that. So I'll get those entered in for you, and we can go from there. So not too much more actually. So we've got another week on arrays and vectors. We're going to look at two-dimensional arrays and vectors, which it'll be tons of fun. People love them on Monday, and then finish up with arrays and vectors on Wednesday. Let's see. Right. And then week after that, objects and classes from chapter 8. We're not going to go super deep on this, deep enough, but this will be a huge topic in CIS 200, which hopefully you're registering for soon. I think registration opened or is about to open. About to open soon. You got your registration holds off, right? Remember there were only like 4 sections when we looked it up, right? Let me see. Let's see what's in here. Enter CIS 200. 5 sections. They added another one. This one's empty though. That's weird. So Monday, Wednesday, 9:30 to 10:45. Tuesday, Thursday, 11 to 12:15. I've not planned to now. Now they've got. I think all these are assigned already. Yeah. So Tuesday, Thursday, 2 to 3:15. Okay, that's sort of reasonable. And then Monday, Wednesday, 9:30 to 10:45, a different one with Dr. Abu Nasser. He's great. Uh, Dr. Shen's great. He's the main tenure track faculty who coordinates the course. He's a great guy, knows a lot of things. Mr. Mann's awesome. Mr. Frost is awesome. Dr. Abu Nasser is great. So this must be like an overflow in case they need a third one here, or a fifth one, sorry. So of your 4 choices, right, 2 of them start at 9:30 in the morning. Maybe you're morning people and you're better people than I am. You might like that, but um, go and check that soon before your options fill up. And then there's also the matching lab. I guess I should search that for lab too, because the lab time matters, right?
Registration either began Monday for College of Business or tomorrow for regular registration.
Okay, so nice of them to let COB register early. Yeah, so here's the labs. So 2 to 3:45 with the 9:30 pairing. Tuesday 2 to 3:45 with the 11 a.m. class. Thursday 4 to 5:45. This one's a little rough here with the 2 p.m. class, or Monday 4 to 5:45 with the was another morning class, right? Anyway, so go register. She picked it up early. And if things are not going as well as you want, right? We've got the tutoring center, Engineering Success Center for Walk-in Tutoring. Has anyone gone and seen him? He seems really nice. Okay. Uh, uh, if he is nice, great. Let me know, and I can tell the director there he's really nice. And if he's not nice, tell me that too, and I'll tell the director he's not very nice. Your name doesn't have to be attached. It's okay. Uh, so we good? All right. We got the project to work on, right? That one's out here already, right? We talked about it. Ticketmaster project. Okay. So when you deal with files, right, we need to think about reading and writing. They go hand in hand. If you're going to read it a certain way, you have to write it a certain way. If you want to write it a certain way, you have to read it that certain way. So just make sure we know how we're going to pair those together here as we go. So we've got till the 13th on this one. Okay. Make sure we get started on that. Awesome. That's all we got today then. We'll pick it back up on Monday.
Question for